I'm going to have a discussion around the content that which all topics we are going to cover during this SD-WAN training. So for that, ideally, I would take the example from, or I would copy the content from this cisco.com, right? So I will just go to cisco.com and I will share. Let me pull the screen. So yeah, this is cisco.com and we're gonna follow the official content, right? So if you look at here, there are multiple options, right? So like here you can see certifications, training, career, and all that. So if you go to certifications, so it will take you to the certifications, right? That okay, these are the different types of certifications that you can obtain here. If you go up, also, like for example, if you click here, browse certification, or maybe you could directly click on learn and then certifications and then browse all certifications. This is how the certifications are categorized within Cisco, right? So for enterprise, that's where the SD-WAN will come into the picture. So you have got the professional level certification, which that's where you would get this SD-WAN certification. So if you go down now, you would get this ENSDWI, right? So that's where verify your skill with Cisco SD-WAN solution, including SD-WAN architecture, controller deployment, policies, and security. If you click here, then you will get to know that what all sort of topics are included in this exam, right? So you could see review exam topics. So if you click here, you would get to know that overall your training, SD-WAN training, is divided into 6 small parts. So the first one is architecture. That's where you learn about that what is SD-WAN, how does it work. There are some terminologies like TLOGs or OMP. So we learn about them, that what is OMP, what is TLOG, right? What is BFD, what is IPsec, right? So, and also this is one of the topics that ideally I cover in the end, like SD-WAN Cloud on-ramp services, also known as Cloud Express. So earlier we used to call it, like Viptela used to call it Cloud Express, but Cisco calls it Cloud on-ramp services, right? So that we will cover in the end of the training. But yes, this topic is also there, right? Then the controller deployment, that's where you will learn that how we can deploy the control components. And if you look at here, the configuration certificates and device list. So ideally it's a description, but we're going to perform the on-prem deployment. Like we will be performing the labs for on-prem deployment. And then we have got the router deployment. And when it comes to the router deployment, obviously you can have the hardware routers as well as virtual router. Although in labs, we have got only the virtual routers. So when it comes to the hands-on labs, right, we are going to perform hands-on labs by leveraging the virtual devices. So in our lab, we have got all virtual routers, virtual control components. Obviously, when it comes to the controller component, Cisco does not offer any hardware-based control component as of today. Like if I take a couple of examples like vManage, right? So vManage is a control component, right? And then vSmart is also another control component. And Cisco does not offer them as a hardware. So if you ask Cisco that, hey, we need the hardware for vManage, right? Or we need a hardware for vManage or vSmart, whatever, right? But as of today, Cisco does not offer any hardware for these control components. So you can either install them or you can deploy them in cloud, right? So whether it is a public cloud or private cloud. So public cloud is like AWS, Azure. When I say private cloud, which means that if you have got a data center where you are having like a lot of servers, so you have got compute power as well as the storage, right? And that's where like you are running maybe KVM or maybe ESXi as an hypervisor. So as hypervisor, if you're using either ESXi or KVM, then on top of that, you can deploy these control components. At the end of the day, those are the virtual components. So the controllers are not hardware, were never hardware, right? And when it comes to the router, obviously router can be hardware as well as virtual. Although for the physical locations, you will always have the physical routers, but for cloud, you would always have kind of like virtual routers. That's that. So once you are done with the router deployment, then you will cover the policies. And in policies, you basically change the topology. That's the most important part here in SD-WAN. Like you can, like if you look at the default behavior of the Cisco SD-WAN, that follows the rule of full mesh. So by default, it creates a full mesh topology, which means that all your spokes, all your remote sites will be interconnected to each other. They all can talk to each other directly, right, through the IP sector. Because in SD-WAN, by default, the IP sector will get established between the remote sites, right? And that happens dynamically. You don't do anything for that, right? Vineet, you are raising your hand. You don't have to raise your hand, actually. No, don't do that. Just go ahead and mute yourself and ask your question. And one more thing that um, I would like to inform you all. Whenever you have got a question, you don't have to raise your hands. Please do not raise your hand. Just go ahead and mute yourself and ask questions. Stop me and ask questions. All of you are allowed. All of you are, permitted to stop me at any point of time in the middle of the topic or when starting my topic. No matter. It does not really matter for me.
Yeah. Okay, sir. Thanks for the information. So I have just one small query. So I just want to know if this SD-WAN. So do we need any prerequisite for this course?
Routing. You should be okay with routing.
The routing, right?
Yeah.
Okay.
Because if you don't have any ideas about the routing, then you can't really learn the SD-WAN, right?
Mm-hmm. Okay.
Because it's not always right to say, or it's not a right statement that always you always going to have your lane subnets as directly connected subnets, right? Sometimes you may have to perform dynamic routing. So yeah, routing should be good.
Okay.
If you're not good with routing, then yes, it will be a problematic then, right? It will be difficult for you to learn or to understand the SD-WAN technology then.
Okay.
Yeah. All right. So then policies, and as I said, that the default behavior of the Cisco SD-WAN is to establish what full mesh connectivity between the remote sites and of course including data centers or regional offices. So like all will establish the full mesh connectivity, right? But then you may want to configure it as a hub and spoke, right? Or maybe partial mesh, or maybe for certain departments you want to have it like full mesh, but for certain other department you want to have it um, kind of hub and spoke type of connectivity. Why? Like I don't know if you have heard about the banking system, right? In banking system, one of the compliance is a PCI compliance, and it's very famous, right? PCI compliance. So you need to follow the PCI compliance when it comes to the banking customers, right? So for banking customers, you will always have to follow that PCI compliance. And as per that PCI compliance, only your let's say card readers, right, or your ATM machines or whatever, right? Those machines must be able to communicate with the payment servers or whatever hosted in data center, right? But those machines should not be able to communicate with each other, right? So that's where you would be needing to have kind of hub and spoke topology. So it's mandatory for you to have the hub and spoke type of topology for a PCI compliant network, right? So that's why it would be needing for you to change the topology, like from full mesh to hub and spoke, or maybe partial mesh and maybe hybrid. As I mentioned, for certain departments, you may want to configure it as full mesh, and for certain other departments, you may want to configure it as there can be different requirements can come from different customers, right? So different customers will always come with different requirements. Then we have got security and quality of service here. So obviously in Cisco SD-WAN, some security features are supported. So mostly those are description, right? But we're going to perform the labs, like especially for service ingestion, as well as for application aware firewall, IPS URL filtering. We are going to perform we are going to perform labs for, not for all, like TrustSec, I'm not going to perform the lab. I will simply explain it. DNS security, I will perform the integration. The SIG, I will show you that how you can perform the integration, right? Then quality of service, that's the configuration, and that we're going to perform the configuration for all these topics like scheduling, queuing, shaping, policing, marking, right? So we can perform all those labs when it comes to the quality of service, right? And for security also, mostly we will be performing lab for each and every feature, but there are a couple of things that we cannot test, like for SIG, right? SIG is there's nothing to do on the SD-WAN except doing the integration between your managed routers and Cisco Umbrella Cloud. But for doing so, you must have the subscription to the Cisco Umbrella Cloud. So if you do not have the subscription to the some Cisco Umbrella Cloud, Cisco Umbrella without having Cisco Umbrella Cloud, or maybe kind of Zscaler Cloud, then or maybe Prisma, Palo Alto Prisma, it is not going to be possible for you to test, especially this SIG, secure internet gateway. So you are totally dependent over Cisco Umbrella or Zscaler type of cloud security solution. So that's why I mentioned that it will not be possible to perform the labs for those features. But then we have got like the last topic, apart from like security and quality of service, management and operations, right? So describe, authentication, monitoring, reporting. So these all small topics are going to be covered. In fact, I don't really have to cover this topic separately, because we can cover all these topics as we go further, right? Like obviously, like authentication, how authentication is taking place between different components, that we are going to cover in the beginning. So we don't really have to wait until the end of training, right? And then monitoring also, the reporting also, right? The authentication configuration, right? So we are going to make that configuration in the beginning, right? We will not be waiting for the end of the training. And then REST API monitoring, right? So I will be covering that visual API. Like basically, I will show you that how you can open up the API documentation, and then which all APIs are supported by vManage, so that you could integrate your third-party monitoring tools such as ServiceNow, right? I'm just giving you one example here for the REST API use case. So if you have got ServiceNow, right, and obviously you know that ServiceNow is a ticketing tool, right? But what you want is that in case if there is an alarm, generated on the vManage, right? So there is a concept of alarms, right? So you would see that sometimes your vManage would generate the alarm messages. So if there is an alarm, then I want my ServiceNow to generate a ticket automatically and to put it in a queue, in a specific queue, right? So obviously, then your ServiceNow must be able to communicate with the vManage. So how are you going to establish that communication between ServiceNow and vManage? So nowadays we are mostly using REST API for that type of work. So from ServiceNow, or between ServiceNow and vManage, you can perform the integration by leveraging the REST API. So I will show you the documentation, right? We can open up that REST API documents on the vManage, right? And that can give us a list of all the API calls which it supports. So that's what we will be doing then, right? REST API monitoring, right? So we will see that. And then the upgradation of the different components, right? So you can also upgrade the different components by, you will learn that how can we perform the software upgradation using vManage. So basically, vManage is a management plane here in Cisco SD-WAN that you would always have access, right? You would always have access to through the GUI, graphical user interface, right? So vManage is kind of like single pane of glass. Like you do everything from vManage, whether it is monitoring, troubleshooting, or making new configurations, or creating policies, or configuring quality of service, whatever, right? Whatever you are doing in SD-WAN, you can do it from vManage, right? So vManage is kind of single pane of glass. Not only it helps you to onboard your devices, but also to monitor them and to make the configuration. So you do everything from vManage. And even it supports like software upgradation, right, from vManage. So like you have got so many other components as well, but you don't really have to log in onto those components for doing the software upgradation. So the software upgrade can also be, or can be performed by vManage itself. So on vManage, what you can do, you can load all the upgrade image for all the components, and then you can simply upgrade the devices, right? You can simply upgrade their operating systems by setting on vManage itself. You don't have to go to any other device. Even you can reboot them from the vManage itself. So that's why we call it like single pane of glass, right? So you will be doing everything from vManage, right? So now you can see, or you saw that how your training is divided into 6 smaller parts, right? And we are going to cover all those topics, right? So now I will open up the PPTs and I will just go through them, right? So that I can give you the list of the labs that we are going to cover. So just give me a sec. Okay. So as I told you, the architecture, then controller deployment, router deployment, and then policies, and then security and quality of service, and finally management and operations. So same we have here. And these are the labs that we are going to perform. So if you look at here, creating SD-WAN overlay, underlay, initializing the controllers, then WAN edges, then templates, and then routing for transport side as well as for service side, like for lane side and WAN side. So here we call it lane and WAN, right? And then we have got control policies, then we have got data policies, we have got security policies, cloud on ramp features, and then day two operations. So in total, you have got like 51 labs. So almost we are going to perform 51 labs during our training, right? And this is the lab environment. This is the lab diagram that we are going to follow, right? So if you look at here, because understanding lab is very important to take this training, and even you will be doing the practice on same lab, right? So if you look at here, so there is one ISP and there is one MPLS. So I'm using two different transports. So one more thing that I would like to explain you that these service providers, right, like internet, MPLS, we were already using those transports, and even in SD-WAN, we are going to use the same transport. So SD-WAN is a transport independent technology, right? It's not like SD-WAN can be implemented with MPLS only or maybe with internet only. So it all depends upon you that which sort of transport you want to use for your customer. One more thing that I would like to specify as well, that this lab environment is built in such a way that you are deploying the SD-WAN for a enterprise customer. For a enterprise customer, like you have got an enterprise customer which has a data center and then couple of remote sites. That's where they have got like sort of WAN connections like MPLS and internet. So it's an example of the enterprise customer. It could be a banking customer, it could be a non-banking customer. That all depends, right? But the example or the topology that we have constructed here is from a enterprise customer point of view. Now, even you would feel or you would see that even the ISPs, the internet service providers, right? The service providers, rather, I would say, because whether those are MPLS providers or internet service providers. So when I take an example of the provider, even the providers like Tata, Airtel, they are moving their core network right onto, like they are moving towards the SD-WAN itself. So even the provider's network will be moving onto the SD-WAN. But we have not built this topology in such a way so that we could explain you that how SD-WAN is going to work for the service providers. Why? Because mostly SD-WAN is famous for the enterprise customers, right? I'm not saying that it's not famous for service providers. Equally, it is famous for service providers, but we are not going to create a network for the service provider. And there is a reason behind that, because we're not covering like CCNP service provider and so that's the reason that I'm not going to talk about more about the service provider, right? So we gonna learn this SD-WAN technology, that how you can really deploy this SD-WAN technology for an enterprise customer, right? Like where you have got a data center, the physical data center, and even sometimes you may have your couple of applications hosted in a cloud-based DC or in a cloud, like in AWS or in Azure, right? So that's where you may get you may get your applications hosted. So the ISP, and then yeah, we have got this software defined wide area. As I said, the ISPs can also use the SD-WAN in their internal network. So I'm not going to have a discussion around that, right? Let's talk about our topology or our network, our infrastructure here, right? Our lab. So we have got two providers here. One is MPLS, the other one is internet, right? So you can see remote sites are having internet connectivity as well as the MPLS connectivity. So you can see at site 2 as well as at site 3, right? So we have got MPLS connectivity as well as the internet connectivity. And similarly in DC, we have got internet MPLS both, and then it is going on this CH router. Now remember, or you just need to look at that we have got one CH router which can be a AS come on, which can be a CSR 1000V or the Catalyst 8000V, right? So that depends whether you are using the CSR 1000V or Catalyst 8000V. That can be a CH, the virtual CS. It is a virtual router, right? But in case of the Viptela, old Viptela routers, that was like VH Cloud, right? So earlier we used to call it. Not basically, I'm not saying that we used to call it. I would say that these are different devices actually, because the Viptela edge router came from Viptela, and when I say C edge, which means it came from Cisco. So whenever we talk about the WAN edge routers, right, which you are installing at customer site, so these all are the WAN edge router, right? So now let me make you a little comfortable with this terminology as well, the WAN edge, right? So you should be comfortable with this terminology. So we are always going to call a router as a WAN edge router at customer site, which connects a customer site to the WAN, like internet or maybe MPLS, right? So you can see that MPLS and internet is terminating on this router, right? So you will call it a WAN edge router. Maybe you have some other layer 3 devices or maybe routers behind the WAN edge routers at lane side. That is okay, right? You may have that, but you would have only couple of WAN edge routers, or maybe just one. Like if you look at the site 2, we have got just one WAN edge router. So the sites like site 1, right? Ideally, like if you have got two WAN edge routers, then you would call it dual CPE site, dual CPE. The site 2, where you have got like one WAN edge router only, then you will call it a single CPE site. So dual CPE and then single CPE site, right? And I mean, that's how you call them actually, right? So you can see that at site 1, we have got site 1 is our dual CPE site, and site 2 is a single CPE site, and then site 3 is again dual CPE site, right? So we have got all those sites over there, right? And then DC, ideally DC will always be dual CPE minimum, right? Minimum, at minimum it will be dual CPE, but due to less due to constrained resources, right, or limited resources, I would say, we had to use only one CS router in DC, right? But ideally, you would see that even in data center, you would have like dual CPE, right? Your data center will always be dual CPE, just to eliminate any kind of possibility of single point of failure, right? So that's how this lab is constructed. And then, as I mentioned, that SD-WAN, in SD-WAN, basically, if we talk about the SD-WAN, right, you are going to manage only WAN edge routers. So if you have got like in backend, you have layer 3 switch or maybe non SD-WAN router, right? It is a non SD-WAN router, right? It's a core router or whatever, right? It's a firewall. So you cannot manage them in SD-WAN. You can't manage them through the vManage, right? So in SD-WAN, you have a management plane or management controller, which is called vManage. So using vManage, you can manage only those devices which are participating in SD-WAN, right? Not those devices which are not participating in SD-WAN, right? So you cannot manage like your lane switches or maybe lane side non-SD-WAN routers or maybe kind of firewalls. You can't manage those components in SD-WAN. Why? Let me tell you. When we talk about the SD-WAN solution, so even before I start and talking about SD-WAN solution, you need to understand the SDN, software-defined networking, right? So I am hoping that all of you now are familiar with that terminology. I'm hoping for that. Just let me know in case if you are not familiar with this terminology, but I'm hoping here that all of you are familiar with this terminology. So SDN is, what is SDN? Software defined networking, which means you are talking about a controller based networking, right? A controller based networking. So nowadays it is so much famous, right? That okay, we must move on to the SDN, we must move on to the software defined networking, right? And in fact, things have moved over to SDN, right? Software defined networking nowadays. Like you are always having kind of centralized controllers, and from there you are managing all of your network devices, right? So you call it controller based networking. So basically in controller based networking, what you have is that you have got a centralized controller, and from there you are going to manage all of your network equipments, network devices, right? When we talk about a Cisco as a vendor, right, as a manufacturer, then in SDN they have got like three different solutions for you, which are related to the SDN. One that they have is SD-WAN, obviously. SD-WAN is one of them. Then they have got SDA, and also they have got the ACI, right? So if you are aware with this a little, like in SD-WAN, you are managing only WAN edge routers, only WAN edge routers. I'm talking from a enterprise customer point of view, right? And then in SDA, you are managing like you have a device called DNAC, that's your controller, right? DNS center, right? That's your control, centralized controller, and then you manage all your switches and all your routers. So when I say routers, which means that those are non-SD-WAN routers, those are non-SD-WAN routers, so you manage them. But these all are Catalyst switches only, Catalyst switches, right? Not the Nexus switches. For Nexus switches, which are usually installed in your data center, for that we have got the ACI controller, right? So this is for Nexus switches, which are ideally installed in your data centers. So in data centers, like you would see the ACI is deployed, and then for the enterprise networking, right? Especially for the LAN devices like your Catalyst switches and the non-SD-WAN routers, you have got DNAC, and basically you can create SDA fabric kind of thing, right? So for that you have got DNAC. So for your LAN devices, you have got SDA or DNAC, and then SD-WAN is to manage your managed routers, right? So basically, and these are the only three components, right? When you talk about a network architecture, right? So let's say you have got DC1 and then you have got DC2, right, for a customer, right? And they have got like multiple transport connectivity, MPLS, as well as maybe internet at both DCs, right? Like this. And then if you have a branch office one, right, you have got the MPLS internet both, maybe branch office 2, MPLS internet both, right? Branch office 3, maybe MPLS internet both, right? So obviously in DC you would be running like kind of ACI, right? But in DC, if you have got a VANEDGE router, right? VANEDGE router, which connects yourself to MPLS or internet. Even you have got VANEDGE routers at branch offices, that's where you will be implementing SD-WAN. And in branches, if you have got like large branches, that's where you have L3 switches, maybe sort of firewalls or maybe routers, right? So obviously firewalls cannot be managed through the DNAC as of today, but yeah, layer 3 switches like Catalyst switches and the WLCs, and even the ICE policies, and so all those things can be managed through the DNA controller, right? So that's where the DNA controller will come into the picture, right? So if you look at here, that Cisco is providing you kind of like end-to-end solution when it comes to the software-defined networking, right? So they have got SDN for data centers, they have got SDN for LAN devices, they have got SDN for managed routers, right? So that's what you have as of today, isn't? Have you understood it now? Kanchi, Praveen, Vineet?
Yes, sir. Understand.
Yes.
Yes.
Okay, cool. So, and so basically, when it comes to the Cisco vendor, right? And when it comes to the SDN, software defined networking, right? We are going to cover, or we are covering just one component of it, right? Praveen, मतलब हमारे पास तीन ऑप्शन है SDN में, SD-WAN, SDA एंड थर्ड
ACI.
वन इज ACI, राइट? अब इन तीनों में से हम जो कवर करने वाले हैं, दैट इज जस्ट वन कंपोनेंट एंड दैट इज SD-WAN, राइट?
Yes, correct.
So don't think that once you are done with SD-WAN that you are good with SDN, right? No, it's just one portion of the SDN, right? So earlier, like if we talk about the traditional networking, right? So if you had the internet connectivity, and then probably this was the MPLS connectivity or maybe Metro Ethernet, whatever, right? You had customer edge routers even before. And over the internet, ideally, you were deploying the DMVPN or site-to-site tunnels, right? And over the MPLS, that MPLS was your primary circuit. And in case if that goes down, then you will send your traffic from one machine to another or from one location to another location using the IPsec tunnel, right, over the internet. And that internet connection was always working as a backup link for you. And then in that condition, each router was managing its control plane as well as the data plane. So if you were running like over the DMVP, and if you are running BGP, even sometimes BGP is running between P and C over the MPLS, right? So even in MPLS, you were running BGP as a routing protocol, or maybe OSPF, right? So that depends, or maybe you were depending on static routing. But point is that all routers were managing their control plane independently, locally on each router, right? And obviously they had their data plane as well, right? The Ceph table, Ceph was always running there. So traditionally, all routers had their own management plane, like maybe SSH as an MPA, all those sort of things. They had their own management plane, they had their own control plane, they had their own data planes independently, right? So if I needed to modify, let's say, in OSPF, or maybe I was running BGP, and in BGP I wanted to define a best path as a DMVPN tunnel for certain prefixes. So you have to go to this router, right? And you will have to modify the BGP policy, kind of like route map if you were using that, right? And then on CE2 also you will have to go there again, and then you will have to make certain changes to the BGP configuration, and then only you would be able to modify the policy. And that's how if you have got like 500 sites, you need to go to all 500 sites, you need to go to all 500 routers, and you will be making changes independently on all 500 routers. And that was a small change, because for a couple of prefixes you just wanted your DMVPN or that internet circuit to be a best path, right? But you had to move on all of the devices independently. You had to make the changes on all the devices, right, locally. And it will take time if you have got like 500 sites, then, or 500 routers, right? So obviously it is going to take longer, or it is going to take a very, very long time for you to make certain changes. So we had those issues with the traditional networking. And I will give you a couple of more pain points, right, that we observed while working on traditional networking. What about if, let's say, you had just one internet connection, DMVPN was running there, and you modified the WAN facing ACL, and somehow a wrong entry was created, and then you lost access. So would you be able, like you are sitting here in headquarters, right? But in branch, there was an ACL on WAN facing interface, and that got modified accidentally. You lost the access. Now, is there any way to was there any way to roll back that change, or to restore the connection, unless you ask some field engineer to visit the place and then to make the necessary changes? I don't know how many of you have observed this issue in past, but yeah, that's a, like, I have seen my lot of friends that went through, those went through this issue, right? So that was one of the major issue that we had before. And apart from that, what if somebody accidentally shut down the WAN facing interface? Again, you have dependency over the field engineer, because remotely you can't control anything there, right? So we had all those issues. You were making changes locally on the devices. Now let me give you one more example. Let's say you needed to modify the NTP server IP, because NTP server IP address was recently changed, and you needed to modify that. You have got 500 branches. So in each branch you have got like one or two routers. So somewhere around 750 routers over there, or maybe around 800 routers. So if you need to modify this NTP server IP address on all 800 devices, just imagine that how much time it is going to take, isn't?
More
And
than
we
hour,
did
sir.
it in previously we have done this manually, right? I do remember that in 2015, or 16, I would say. In 2016, we had like ASA firewalls, and obviously, you know that in ASA we had CSM as a centralized controller, but that was only for policy building, not for NTP server configuration or SNMP keys. So for somehow we got SNMP compromised, right? SNMP string compromised, right? So that was compromised, and then we had to modify that SNMP community string everywhere on all the ASAs, and we had around like 1200 ASAs in that infrastructure, right? So we had 1200 firewalls. We needed to move on to all 200 1200 firewalls, and I still remember that people worked like in rotational shifts, you know, like okay. And even we borrowed engineer from other teams as well for a couple of days so that we could finish this work right on time. So I have seen that. Like I don't know about you, but I have seen that those small things took really long, and then also too much manual efforts, right? So that was a problem. Now, if you were having a controller-based networking and you needed to modify the NTP server IP, you just go to controller, update there, and then controller should push it across all the 1,000 devices at same time, isn't? Don't you think that it will be so easier? Like it took up even less than a minute, right? And in similar way, if you are looking to update the SNMP community string, just go to controller, modify it, and then push to all devices at same time. So it took a minute, right? So don't you think that yes, it is good idea to have a controller based networking rather than managing all the devices independently locally, right? So we had so many, I would say, uh, pain points, right? As I have given you a couple of examples here, right? So the solution was SD, software defined networking, SDN. That's where the SDN came into the picture, right? And I would help you to understand that how SD-WAN is helping us to mitigate such issues. Like, what if WAN facing interface, we shut down that um, interface accidentally, or maybe the ACL was applied, which blocked everything. So I will explain you that how SD-WAN is helping us to avoid those incidents, right? How SD-WAN is recovering your devices from such conditions. Okay, sir. And now even the requirement, like earlier, the requirement was different. Like you had a DC data center, and ideally backhauling was implemented. I believe that everyone on this call is comfortable with that terminology, backhauling. So traditionally, everyone, like all the remote sites, were connected to the DC, and DC further was connected with the internet, and also all the applications were hosted, like private applications were hosted in the DC. So what was happening is that in DC, like everyone in branch office, whenever they wanted to have access to the internet, they will go to DC, and from DC they will go to internet. And again, the response will come back from the internet on in your DC, and then DC will forward the traffic back to the branch. Initially, it was good, but now you can see that applications are becoming more and more rich. The applications are heavier than before, right? So if you are working on latest applications, obviously you would have to increase the bandwidth, to go to from branch to your data center, right? And also things are getting changed quickly. Like there's a concept of SaaS, software as service. So now customers are using some SaaS based applications, and SaaS based applications can be accessible directly through the internet. But just imagine you are using Office 365, and there is a customer who is using the old technology, right? There's a customer who is using all the technology. So first they will go from branch through the MPLS to data center, and from data center they will go to the internet, and then will have access to the Office 365, right? Just imagine that how much time it might take to deliver the emails then. And there will be a lot of latency, correct? And that applies to so many different other applications as well, right? So now things are hybrid. It's not like all your applications will be hosted in your data center only. No, that's not true statement. Some of your applications are SaaS based applications that customers are using nowadays. Some of the applications will be hosted in on-prem data centers. Some of the applications will be hosted in public cloud as well, like AWS or Azure, which is also known as infrastructure as service. And even there is a concept of the multi-cloud as well. That few applications are hosted in AWS, few applications are hosted in Azure, and so things are changing, right? The internet as is moving towards the branch. Your branch users would be needing internet access. And if you are still providing the internet access to your branch user via data center through the MPLS link, because earlier we were not having the internet connectivity actually in branch offices. We used to have the MPLS connectivity only, right? So MPLS connection was always there at branch, and using MPLS, you were backhaul into the DC. That I'm talking about the traditional networking, right? So obviously it was a problematic then. Like you will have to increase your MPLS bandwidth. Then why are you using MPLS bandwidth for providing the internet access then, right? But now again, if you take the internet connectivity at branch, like if internet is moving at branch, then you must provide security because the internet is insecure transport, right? So you should install the firewalls, and that's where the Cisco launched the secure SD-WAN, right? So when I say secure SD-WAN, which means that Cisco is not only going to provide you the SD-WAN features, but also it will provide you the security features like application aware firewall deployment. Earlier, I don't know if you have heard about that, but on Cisco routers we used to deploy the zone-based firewalls, right? So they have simply, they have made like Cisco has made some advancement into their existing feature called zone-based firewall, and now they have renamed it as application-aware firewall on their managed routers. They have got URL filtering. They have got some other stuff as well, right? And like AMP or maybe IDS IPS. So all those sort of features can get enabled when it comes to the Cisco SD-WAN. Any questions from anyone so far?
Not as of now.
And even if you were using the internet before, then you needed to implement the IPsec tunnel to allow connectivity between the remote sites. I don't know how many of you have implemented the IPsec tunnel, and I don't know how many of you have performed the troubleshooting for IPsec tunnel. Was it so hard? Don't you don't you think that it was so hard to deploy, to implement the IPsec tunnel, and even it was more harder, to perform the troubleshooting then, right? In case if the tunnel was not coming up. So I don't know how many of you are aware with that thing. I have witnessed all those things, and I know the pain of implementing IPsec tunnels and then troubleshooting them in case if the tunnels were not coming up, right? So that's that. I want to keep it short today, right? I don't want to extend it or stretch it for complete 2 hours, right? Like from tomorrow onward, we can have a full session because some more participants are supposed to join this session. So I don't want them to lose anything. So can we keep it short today?
Yeah, okay, sir.
Yeah, sure. Sure.
Praveen?
Yes, no problem. Yes, no problem.
Okay.
No problem.
Okay, so I'll keep it short today, and we'll continue tomorrow then, right from here. Agenda, right? So yesterday we had a discussion about the agenda of this training, right? Like as I already explained it to you, right? So I would request all of you to revisit the lecture that we had yesterday. And yesterday we only covered like the agenda of this training, the number of labs that we are going to cover, the topology that we are going to use. Right. So that's what we discussed yesterday. And also I had a smaller discussion or a small discussion around the requirements of the SD-WAN. Like I discussed about some pain points for like if we are on a traditional network, right? So if we are still using the traditional networking, so I pointed out some pain points, not all, but some pain points I pointed out. So based on those pain points, then I said, okay, that's the reason that we needed some sort of controller-based networking, right? And that's where then I discussed about the different solutions offered by Cisco when it comes to the software-defined networking, right? So that's where I took an example of Cisco SD-WAN, and then also I took an example of the SDA software-defined access by the help of DNAC. Also, I took an example of ACI for data center Nexus switches, right? So that's what we discussed yesterday, but from today and onward, we gonna focus only on the SD-WAN technology, right? Just one thing, I'm not really well, so I'll be a little slower, right? I'll be at slower side, and probably I will not be able to stretch this session for complete 2 hours. My throat has got some infection, right? So I will see that for how long I can stretch this up, right? I will try to stretch it at least for up to an hour or so, like an hour and 30 minutes or so, right? And we'll see, right? I will let you know for this week until I get recovered, right? Okay. So agenda architecture, then controller deployment, right? Then router deployment, and then policies, and then security and quality of service, and then management and operations, right? So let's get started with the architecture now. So if we talk about the solution overview, so yesterday I had this discussion with the participants. I know that yesterday we had pretty much smaller number of all of you who were not present yesterday. Please, I would really advise you to go through that is a quick session, because that video is not for so long, right? That video was recorded for an hour, I believe, so, or maybe 50 minutes. So you can easily go through that video. That's where I have discussed all this stuff, right? The traditional WAN. So even if you look at here now, so traditionally, if you had like two sites, like you can compare, you can take this example, right? So let's say this is site A. Let me just use Epic Pen, and then I will specify that. So let's assume this is site A and this is site B, right? If you want lane users of site A to talk to site B, right? So for that purpose, you had like two different transports available. Let's say this was MPLS connection. So ideally, you would define your MPLS as a primary circuit, as a primary link to go from site A to site B and vice versa. And also you have got internet connection. And on top of internet connection, ideally, if you have just two sites, then you will go for the IPsec tunnel, which is site to site tunnel, or maybe you will use IPsec over, kind of like GRE over IPsec, right? You will go for that GRE over IPsec, or maybe you will go for the DMVPN, right? So that you can enable dynamic routing. See, if you are just implementing site-to-site tunnel, then it does not allow you to configure the dynamic routing protocols, right? It will be simply a policy-based VPN. But if you are implementing GRE over IPsec, then obviously over the GRE tunnel, you can implement the dynamic routing protocols. And that's what DMVPN does, right? So in DMVPN will be used only if you have got multiple sites, like more than two sites. So wherever you have got more than two sites, then go for DMVPN. Now, if routing protocol is implemented over the internet transport as well as over the MPLS transport, you would make sure that your primary circuit is always MPLS, right? In most cases, right? This is how you used to perform things. Each router would have its own management plane, its own control plane, and of course, its own routing table. If you're running a routing protocol, then each router is responsible to maintain that database, right? Like in OSP, if you would have the link state database, also you would have the neighbor table, and also the best routes will be installed in its RIB, which is also known as routing table, right? And then each router is going to have its own data plane. So at both sides, you can see that each router is having everything. So now, if you have just two sites, then probably you might think that, yeah, I mean, that's all right. I will go to both routers and will make the necessary changes, right? Especially for the policy, right? Like, for example, if your primary circuit was MPLS, right? Now you decided that there is a lane subnet behind site B, which is 10.1.70, right? .0/24. For that particular prefix, now you want your internet or DMVPN to be a preferred path, right? So if you want your DMVPN as a preferred path for a specific prefix, right? And let's assume that you have got maybe 500 sites, right? Not just two. So just imagine if you have got 500 sites, then how much time it will take for you, or how much time you would be taking to make all these changes on each individual router. Because if you have configured a policy, then you would be needing to modify, to update that policy across all sites, across all 500 sites, which means that if you have got like 600, 700 routers across all 500 sites, because some of the sites would be like kind of single CPE site for customer, single CPE, and some of them would be dual CPE site. So if I say 500 sites, it does not necessary that you would have only 500 devices or 500 routers, or I would say managed routers. You might have like 700 managed routers or 800 managed routers. If your all 500 sites are dual CPE sites, then obviously you're going to have like 1000 managed routers, right? So when I say managed router, so which means that a router which connects your site to the WAN, whether it is MPLS or internet. So just imagine that how much time it will take to reflect those changes across all 500 sites, right? And not only that, but also I given you one more example. Like if there was a change in NTP server IP address, right? And you have got maybe 1500 devices in total. Let's assume that you have got 1500 devices in total. And you needed to update the NTP server IP across all 1500 devices. So you can think of that how much time it is going to take, right? You can think of easily. So earlier we did it manually, and in fact, I took one more example yesterday that we had SNMP, right, community which got compromised somehow, and then we had like around 1000 firewalls, in fact 1200 firewalls, right? So we needed to update that SNMP community string across all of the firewalls, and that we did manually. And that's where the controller based networking, right, or software defined networking came into the picture. And that's where people started think of software defined networking, that we should have a controller based networking, so that if we get such requirement, like if we needed to update the SNMP community string across all 1000 devices or 1200 devices, or maybe less than that or more than that, you just go to controller, update it, and push the change from the controller right across the firewalls. And that way your changes would get reflect across all the firewalls. Or maybe you can take an example of the router as well. So that's where you needed a kind of controller, a centralized controller from where you could push your changes, right? So that would make your life easy. So I hope that again you have understood the example that I gave you. Also, we had so many other pain points that I discussed in previous session, right? In very first session, please visit that session. And in case if you get any question, please note down those questions, and then you can ask me those questions tomorrow. I also discussed about the change of the requirements, right? Nowadays, like even the requirement for the end users in an organization is changing, right? So if you take an example of the traditional networking, we always had like kind of a DC, mainly we had two DCs, right? DC1 and then DC2. And then the ISP internet connection was always available in DCs, and also MPLS connection was available in DCs, right? So let's say we had MPLS from two different providers in DC, and then if you had a branch office, let's say branch one, that also had MPLS connectivity from both MPLS providers, right? So branch two also had connectivity from both MPLS providers, right? So basically, from remote branches, the traffic was always coming to DC using MPLS circuit, whether it was an internet traffic or it was like maybe users were accessing the application which was locally hosted in this data center. But all traffic was backhauled into DC, whether it was internet or the enterprise data, right? So everything was backhauled into DC. So that was the traditional way of doing networking. That was traditional way of implementing networking, right, for most of the customers, right? Later on, then as a backup link, we started using DMVPN, like we started having internet connection across the remote sites, and then we implemented DMVPN. But the problem with DMVPN was that it was a Cisco proprietary thing, right? So it was needed for you to have the Cisco routers across the sites, right? All right, but now things have changed. How? For example, more and more applications are moving towards the SaaS model. software as service, you can think of Office 365, right? So if this customer has purchased the Office 365, if they have subscribed Office 365, if a branch user is accessing the Outlook, right? So obviously first they will come to come to DC via MPLS, and then they will go to the internet, right? And again, they will come back from internet to DC, and from DC via MPLS, the traffic will come back to the remote branch. Now, there can be various issues because of following this approach. Why? Because it's taking longer time. First, you are backhauling into DC, and then you are going to the internet. It would be better for you for the branch users to go over the internet directly, right? So that they can directly access this software as service based application or SaaS based applications. And that's why the internet as is moving towards the branch, which means that the internet connection should be available at branch. That's one example of SaaS, but also you might have the infrastructure as service. Nowadays, it's time of hybrid kind of networking, right? So sometimes you would see that a customer would have the on-prem data center, but also they would have which sometimes they call as private cloud, right? The on-prem data centers will also be known as private cloud. So if someone has written private cloud, so don't get confused, which means that they are talking about their internal on-prem data center, right? The public cloud is like Amazon, or maybe to say AWS, and then the Microsoft Azure, and then GCP, and so, right? So when it comes to the infrastructure as service, which means that you are deploying some of your applications in cloud, right? So the one way to access those applications which are hosted in AWS, which is going to be like from data center, you establish an IPsec tunnel with your AWS VPC. Like in AWS, I don't know how many of you have heard about this terminology, VPC. So with this VPC, you would have to establish an IPsec tunnel. But the problem would be that if there is a branch user, first they will have to come back. They will have to come into the data center via MPLS in most cases, right? And then only they will go to the cloud, and that would add unnecessary delay, right? So it would affect overall performance of the application for the end users then, right? It would be better because you know that the cloud, AWS, you can reach it from branch directly if there is a direct connection from branch to your VPC, right? So you don't have to backhaul your data into the DC and then will go to the infrastructure as service, or maybe your AWS cloud or Azure cloud, right? So it would be better, or it would be a good idea if we can directly go from branch to the infrastructure as service, right? So that's why the internet as is moving to the branch, right? The other problem you can think of that nowadays the applications are more rich, right? Are more rich and would be needing more and more bandwidth. And if you increase your MPLS bandwidth, let's say you are just doing the backhauling. So all the branch users will go to the DC using MPLS connection only. And if you are providing them, let's say SaaS-based application access, or maybe the application access which are hosted in public clouds, right? And all those applications are accessible for the branch users via DC. So you will have to definitely increase this MPLS bandwidth. Why? Because nowadays the applications are more rich and would be needing more bandwidth, right? Obviously the cost will get increased then, because if you increase the bandwidth of the MPLS circuit, the cost will get increased, right? And all these problems are fixed by the help of SD-WAN, right? And here we are going to learn about the Cisco SD-WAN. So you can see more user requirement, like you may have guest users, you can have IoT devices, you have got headquarters, you have got branches, maybe you would have regional offices, right? More applications are moving into cloud, and then you have got SaaS-based applications. You also have got infrastructure as service, as I told you, and branch sites getting direct internet access, which means that we want we want our branches to directly access the internet. I have already given you the justification behind that, right? But point is that branch users should have the directly, they should have the internet access directly. They should not backhaul into DC, and then from DC they should be, they would go to the internet. So that's not something that we should follow, right? So access at any time from anywhere, right? So that is also another requirement, right? So all these requirements will be fulfilled by the help of SD-WAN. If we talk about the older or the traditional networking, obviously that's complex to operate, difficult to secure, and poor user experience. That these all are the challenges that we had with the traditional networking. Obviously, we started with the traditional networking, but with time we started getting problems with traditional networking, and that's where this SDN software-defined networking, right, came into the picture, right? So insufficient bandwidth, security challenges, limited app awareness, no cloud app readiness. So obviously, the older routers, right, the traditional routers never had application awareness, never. Have you ever heard that on in traditional routing that you said, hey, for YouTube or maybe Facebook, use this circuit, and for rest of the traffic or for rest of the applications, use the different WAN circuit? It was never possible. We never performed, like on routers, we never did application based routing, right? We always performed layer 3 routing. We had IP subnets in the routing table of the routers, right? We got them installed in the routing table, and then the routers were able to switch your IP packets based on the destination IPs only. That's what happened, right? No app awareness was there, right? And no cloud app readiness, because it was not possible for us to do something for the SaaS-based applications and even for infrastructure as service. High cost. Why I'm saying high cost? Because you needed more engineers. Obviously, that's one factor. Second, you needed more bandwidth, more MPLS bandwidth, right? And complex operations. Obviously, you had, as I said, I gave you one example of NTP, right? So you needed to update the NTP server IP address, or you needed to update the SNMP community string, and yes, it will take so long time, right? So that's an example of the complex operations, right? Insufficient bandwidth. I gave you that example as well of the MPLS bandwidth, right? So yeah, because I mean, sometimes in your area, even the provider would not be able to give you, or would not be able to increase your bandwidth. Let's say in your office you want that, hey, I need a connection of 1 Gbps, and if the providers, like no provider have that capacity in that area, then how can they allocate you 1 Gbps of bandwidth, right? So that can also be another problem, right? Now, in software-defined networking, or when we talk about the software-defined networking, basically what you have done, you are segregating things, right? You are segregating things. Like earlier, we had everything on a single device, like especially the control plane and the data plane, right? But here in SDN, software-defined networking, we have got one application layer, business applications, right? And they have divided then control plane, like they have abstracted, right, the control plane from the forwarding plane or data plane devices. So obviously, earlier at the infrastructure layer, which means at the device level, like at all routers, you had your data plane as well as control plane. But now you have abstract the control plane. So in SDN, you would have a centralized control plane, and that you will understand now in some time, right? So let's talk about the Cisco SD-WAN now. Remember that Cisco SD-WAN has also been renamed by Cisco. Now they call it Catalyst SD-WAN. So that is something that you should be aware of, right? Catalyst SD-WAN. So they have renamed it recently, right? As per the Cisco, the gold star images are still those older one, 20.6 and 20.9. We are using 20.6 in our lab, so we are still going to call it Cisco SD-WAN. We will not call it Catalyst SD-WAN. We are not going to see the Catalyst keyword in the available options onto our management plane or vManage, right? So we still will be seeing only the older terminologies, but you don't really have to worry about that, because the meaning is still same, right? I mean, Cisco renamed the components, that is all right, but their functions are still same. There are no differences into their functions, right, or into their functionalities. So as per Cisco, the recommended version is 20.6 and 9. We are using 20.6, but they have launched 20.13. The Catalyst SD-WAN started with 20.12, right? And I believe that Cisco had a lot many issues with that, and that's the reason that Cisco quickly, like I believe that last month only they launched 20.12, and this month they have launched 20.13. So Cisco is making changes to their software at their software side so quickly. So we need to make sure that we are always up to date. We are aware that what's changing, right? What's happening. So that is also one of the important thing that I would recommend you, that you should always visit, or you should keep visiting the Cisco website, and should keep checking that what all sort of new things they have launched, right? Maybe new version or whatever, right? Okay, now let's talk about the Cisco SD-WAN. The Cisco SD-WAN is mainly divided into two portions here, right? One is like your managed routers, right? So you have got your managed routers, also called or also known as data plane devices, right? So you have got data plane, right? That's where you have your physical routers or maybe virtual router, which means that it is all about the routers when we talk about the data plane. But then, as I mentioned before, that we have offloaded the control plane from the data plane devices, and that's where we have got the centralized control plane now, right? So if you look at here, so that's a brain of your Cisco SD-WAN. This whole, like, even you could look at this image, right? So it's like, it looks like a brain, right? So all these components in Cisco SD-WAN architecture, like vManage, vSmart, vBond, these all components are going to work as a brain of this SD-WAN technology, right? So if you look at here in Cisco, if you look at the brain of the Cisco SD-WAN architecture, there are multiple components like vManage, vSmart, vBond. We will go through each one of them. We will try to understand their meanings and their functionalities. But before I go for that, I would also like you to, I would also like you to know that the other vendors, like obviously Cisco is not the only vendor who is providing this SD-WAN solution. There are many other vendors, right, out there in the market providing the SD-WAN solution. I can give you a couple of names such as VeloCloud, which is from VMware, right? Then we have got Silver Peak, right, which is from HP nowadays, or Aruba SD-WAN. You call it HP SD-WAN or Aruba SD-WAN, it's the same thing. And you have got your Versa, you have got Nokia, you have got Juniper CSO, right, or Juniper SD-WAN. So you have got so many different options out there in the market, right? But if you look at the Cisco SD-WAN architecture, basically they are using the distributed architecture. They are using what? Distributed architecture. So why I'm calling it distributed architecture? Like for different functions, they have got different components. Ideally, you would see that other vendors, they are having a common component. Like if you take an example of the Silver Peak, right? They have a centralized controller, right? And that centralized controller is working as a management plane, control plane, and as an orchestrator, right? All functions are integrated onto a single controller, right? So a single controller is working as a management plane, as a control plane, as well as orchestrator, right? So, and that's not only for VeloCloud, that's applicable for Silver Peak equally, right? Which they call, I believe, if I'm not wrong, VC or something like that. So mostly SD-WAN vendors are having a single control component that is acting as an orchestrator, as a management plane, as well as a control plane. But in Cisco, they are using the distributed architecture. So in distributed architecture, they have got different components for different functions. Like vManage is the management plane. So when I say management plane, which means that you are going to manage your SD-WAN technology, or you are going to manage your entire SD-WAN from vManage. You would always have the GUI access to the vManage. So when I say GUI access, which means the graphical user interface, right? So you would always have GUI access to the vManage. And from there, you would make all your configurations, and not only configurations, but also you will be performing troubleshooting from vManage. You would be doing everything from vManage, not only configuration, but also the troubleshooting, and even the design can be created on vManage. You will be onboarding your devices by the help of vManage, right? So vManage is one of the critical component, but remember that it is a management plane. Only you manage things using this vManage, right? So you have got a dedicated component called vManage, and that is going to work as a management plane for you. So you are going to manage the entire architecture, whether those are routers or other components like vMont, vSmart. All these components can be managed through the vManage, right? So it's a management plane. Then you have got a vBond. vBond is nothing but it is an orchestrator, right? So it is an orchestrator. So for orchestration, you don't need any. You don't have dependency over the vManage, right? So we have got a dedicated component that is going to work as an orchestrator. Now, let me ask you one question. So I believe that you guys have some difficulties in understanding the meaning of the orchestrator, if I'm not wrong, right? You never heard this terminology before, right? So let me explain you the use of the orchestrator. All right. So let's talk about the orchestration plane or orchestrator. Also, you can call it vBond, right? So you call it vBond, or you call it orchestration plane, or you call it orchestrator. So that is all right, right? The meaning is same, right? So remember that orchestrator or this vBond is always going to work as a mediator, for the different components. Like what happens is, like in Cisco SD-WAN architecture, what happens is that whenever you power on any component, so when I say any component, which includes your vManage, vSmart, and of course your managed routers. So it's including all of your components here, right? It's including all of your components here, right? I mean, my statement is including all of the components in this architecture. So point is that whenever you power on any device, the first thing it will ever do is to go to vMont. That's the first thing that all the devices will do. So all the components will first go to vBond, will try to authenticate themselves with the vBond. If they get authenticated with vBond successfully, then only vBond will provide all the necessary information to this component so that this can talk to your control components as well as the management plane. So it's like a mediator, right? So the orchestrator is responsible, right, to initiate or to orchestrate the connectivity between the different components, right? So as I gave you an example of the managed router, when you power on a managed router, first it will go to vBond. Now you could ask me that how can it go to vBond? So it is mandatory for us to tell a managed router that who is the vBond. So it is mandatory for us. So we always configure the IP address of the vBond onto a managed router manually. Although this statement is not really true, but for now, I will make this statement, right? So it is mandatory for us to define the vBond IP address on this managed router so that it knows that who the vBond is, right? So once it reaches out to the vBond, right, then it will try to authenticate itself with the vBond. If the authentication was successful, then vBond will have the controller list, like the list of vSmarts, the list of vManages, and then it will provide that list of controllers to the managed router. And then your managed router would establish the connectivity or the connection with vManage and the vSmart controller. So if there is no vBond, if there is no orchestrator, you cannot onboard your managed routers. And even forget about that. If you have one vSmart, right, and you just powered on it, already you were running like a couple of more vSmarts, those were already present, but this vSmart will also go to vMont. If vMont sees that, okay, there is one more vSmart now, so it will provide the list of existing vSmarts to this new vSmart, and also it will provide the information of this new vSmart to the existing vSmarts. So that is also done by the vBond. So vBond is an orchestrator. So I believe that now you have understood the meaning of the orchestration keyword, right? I'll go back again, right? And yeah, that's the architecture. This is Cisco SD-WAN architecture. That's where we have got this brain of the SD-WAN. So now remember this vManage and vSmart, right? vSmart, because vSmart is a control plane, right? As I told you before, that we are going to offload the control plane functionality from the managed routers. So we have offloaded the control plane functionality or control plane from the branch managed routers, and we kept the control plane as a centralized control plane, right, in the form of vSmart. So remember that vSmart is going to work as a control component or control plane components here, right? And vAnalytics is kind of like it works based on the opt-in model. Like it's up to you if you want to opt the vAnalytics or not. It's not a mandatory component. It does not participate in any process of the SD-WAN architecture. The only purpose of vAnalytics is to get the analytical reports. Like you can get rich analytical reports that you can represent to your higher management to show them what's happening in your network, like how much of bandwidth utilization, which is the most used applications, which are the most used applications in your organization, which user is accessing the most amount of data, and all that kind of stuff can be seen in the vAnalytics reports, right? So this vAnalytics is kind of like SaaS-based portal offered by Cisco that would help you to generate the reports, the interactive reports, right? So it doesn't do anything when it comes to troubleshooting or making configuration onto devices. So if you even if you do not have the vAnalytics access, that is okay, all right. I mean, it would not affect anything onto the Cisco SD-WAN architecture. And one of the most important thing that I would like to bring up here for SD-WAN is that you do not depend on the transportation, right? The transport is still same. Like if you want to use MPLS, use MPLS. If you want to if you want to use the internet, use internet. If you want to, even if you want to use the LG 4G or LTE or 5G, use them, right? You have Metro Ethernet connection. Use Metro Ethernet connection. So SD-WAN is a transport independent technology, right? So you can still have any transport, any type of transport. It would not make any, I would say, differences here, right? So you have got MPLS, you have got internet, you have got 4G, and earlier we had kind of similar thing, right? Although we were not having kind of 4G LTE, but we were using 4G LTE through the wireless, and then we were connecting that through some sort of wire. Then we were providing wired connectivity to the physical routers. But yes, there was a way, or we had some ways to use 4G LTE for the old routers as well. But those were different devices that we used for the LG and for the 4G and LTE networks. But in SD-WAN, if you even look at the routers that now we have got routers from different vendors, you can even insert the SIM. You can even insert the SIM card to those routers, right? And then that router can start using 4G LTE kind of connectivity or 5G connectivity. So the transport can be anything. So it's up to you whether you want to use MPLS internet, right? Although we say that this SD-WAN has replaced the MPLS, so don't say that it has replaced the MPLS. I would rather say that it has reduced the requirement. It has reduced the requirement of the MPLS. That is something that I would say for sure, right? That it has reduced the requirement of the MPLS, right? But it has not replaced the MPLS, because if some customer still wants to use MPLS, then use MPLS, right? If they want to use the internet, then yeah, they will use the internet, right? Even they can use the broadband connectivity. So when it comes to the internet, you get two different types of internet connectivity. One is called ILL, internet released line, and the second is called broadband. So in SD-WAN, that gives you flexibility to even use the broadband type of internet connection, right? So at remote sites, you can use the broadband connectivity, right? And yeah, that's that. And one more thing that I would like to explain here is that in SD-WAN, in Cisco SD-WAN, all your remote sites. So you can see that in this example, the remote sites could be in your cloud. So that's where you say infrastructure as service, could be your data center, could be your campus network, could be your branch, and could be a colo, right? Or Soho kind of thing. we have multiple branches, multiple DCs, maybe multiple campuses. All these managed routers are always going to have a secure connectivity between themselves, and that's a data plane connectivity. That's why there is a log button, green log button, because the IPsec tunnel. So the IPsec tunnel would come up between the remote sites or between remote site routers automatically. You don't have to make any configurations for establishing the IPsec tunnel. If you remember that we used to have the DMVPN before on the Cisco routers, right? But just imagine that how difficult it was to manage the DMVPN. Initial configuration was too difficult, and then performing, doing troubleshooting was difficult. Even if you were implementing like kind of site to site tunnel, again, the configuration was complex and troubleshooting was also complex. But in Cisco SD-WAN, these IPsec tunnels between remote sites would come up automatically. You don't do anything for that. Even you don't execute a single command. You don't even define the pre-shared key. That is also shared by the devices automatically by themselves. And that's why we are calling it software-defined networking, because software is doing that for yourself, right? You're not doing it manually. So all these IPsec tunnels or secure connectivity between the remote sites would come up automatically. You would not be doing anything extra, or you would not be making any configuration for that. So remember that SD-WAN is going to provide you a secure connectivity between the remote sites. Now, since SD-WAN is providing you a secure connectivity between remote sites, so no matter what type of transport you are using, if it is MPLS, fine. Over the MPLS, it will establish an IPsec tunnel. If it is internet, again, it will establish an IPsec tunnel. If it is 4G, again, it will establish an IPsec tunnel using 4G between the remote sites, right? At the end of the day, there is a secure connectivity, no matter what type of transport you are using, right? So over MPLS, there is an IPsec tunnel. Over the internet, there is an IPsec tunnel. Over 4G LTE network, there is an IPsec tunnel. Therefore, the traffic is going from one site to another site securely through the tunnel. And that's why now people said, hey, because we are already establishing a tunnel, secure tunnel between the remote sites, then why are you still using MPLS? Right? Why are you still using MPLS? You don't need MPLS, because earlier we had MPLS because of the security, right? We never wanted our branch network exposed over the internet, right? But now they are saying, like we are saying, the SD-WAN providers are saying that over the internet, we will give you a secure connectivity. We'll secure your data using IPsec tunnel. So why do you still use MPLS? So that's how you try to convince your customer, your customer, to remove the MPLS from their environment. But sometimes they will probably keep this MPLS only for voice over IP. That they will say that, okay, let's reduce the bandwidth of the MPLS. Let's keep the voice over IP data through the MPLS only. So, or maybe they have got just one critical app that they don't want to, let's say the customer just said that, hey, this is the critical app, the most critical app that we are using here for the internal users only, that is hosted in our data center only. So I want the branch users to access that critical app via MPLS from the data center. So probably they still want to use MPLS, but for certain applications, not for everything. So you can reduce the MPLS bandwidth. Even for VoIP, there is a solution in different SD-WAN technologies, especially in Cisco SD-WAN. There is a feature that if you have got two internet, ISP1 and ISP2 in the branch office, right? And then you have got another branch office, which is also containing both internet connectivity. So over the internet, there will be an IPsec tunnel, right? There will be an IPsec tunnel between the remote sites. If you are making a call from this branch to another branch, like from branch 1 to branch 2, and you want, you do not have any MPLS connectivity, right? You are having only internet connectivity. So for voice over IP, ideally, we do not use internet. Why? Because of the drops, because you get drops anyhow over the internet. I mean, that happens. You can't stop it, right? So you get drops. Now, if there is a drop, then obviously the quality of the voice call would be degraded, obviously. right? Or would be poor, right? The voice quality would be poor. But what Cisco says that do one thing, don't use MPLS, use packet duplication. Like you have got two internet connectivity, right? You have got redundant IPsec tunnel between the branches. And for voice over IP, for SIP, let's say you're using SIP, right? For SIP, use packet duplication. Packet duplication would enforce router to send the packets through the both IPsec tunnel. So in case if the packet was dropped via one of the IPsec tunnel, it will get delivered through the another tunnel. So that packet duplication feature is also available. And that's how you, again, try to convince your customer to completely get rid of MPLS, that completely have internet connectivity only, right? Just remove the MPLS. So, I mean, obviously the SD-WAN, when Cisco is pitching the SD-WAN solution to their customer, then Cisco will always try to make a lot of statements which would, which could help Cisco to sell their solution to the customer, right? Because they also they are also wanting that the customer should move on to the Cisco SD-WAN, and then slowly they will start pitching up the SD, and then finally for data centers they can start thinking of ACI. Although many customers have started or have already migrated over the ACI, but ACI is quite expensive solution. So I mean, for smaller customers, it's really not feasible for them to migrate their data centers from older technology to the ACI. But yeah, I mean, Cisco is focusing on all these three technologies nowadays when it comes to the software-defined networking, right? The ACI as well as the SDA as well as SD-WAN. But here we are going to talk about the SD-WAN only. One more thing that I even mentioned yesterday, and I'm making that statement today again, is that using this vManage or this SD-WAN controller, right? This is SD-WAN controller, right? vManage. Only you can manage your managed routers. So behind, let's say, branch, you have got a layer 3 switch, or maybe a router, or maybe a firewall. You can't manage them through this vManage. No, that's not possible. So only managed routers. And you must be knowing that who all are the managed routers. So the router which are connected to the WAN, like to the internet or to the MPLS, and they support SD-WAN, then only they can be managed through the vManage, right? And yesterday I also spoke about the Viptela and Cisco, the history of Cisco SD-WAN, that how it started with Viptela, and then in 2017 Cisco acquired Viptela, and that's how the Viptela became Cisco SD-WAN. The Viptela SD-WAN became Cisco SD-WAN, and that's the reason that when it comes to the managed router, we have got two different options: the V-edges. V-edges are those as routers which came from Viptela, and C-edges are from Cisco, right? When it comes to the managed router, so V-edges will still use the Viptela OS, right? Viptela OS, whereas the C-edges will use the IOSXE with SD-WAN capability. So your IOSXE should be SD-WAN capable.
Sir, one doubt.
Mm-hmm.
Sir, VH, vSmart, and vBond and vManager connected to authentication vManager. Some, if in case vManager is down, total production is down, sir.
No. That's the beauty of this architecture. No? That's why I made that statement that in most vendors, they have a centralized component that is acting as a management plane, as a control plane in vBond. But here you have got a distributed architecture, right? So if vManage goes down, there is no impact on vBond and vSmart, right? If vBond goes down, there is no impact on vSmart. The control plane is still working, right? So the thing is that if vBond goes down, then new sites will not be onboarded, or maybe if you reboot a managed router at one of the site, then it will not be onboarded, but all your existing connectivity will remain there, right? Existing connections will keep working. Same goes with vManage. If vManage goes down, still there will not be any impact on existing connectivity. The only difference would be that you would not be able to make any changes, right? But there will not be any impact on the existing connectivity. Same goes with vSmart. Even vSmart goes down, although it is a control plane and very, very critical component of the SD-WAN, right? Cisco SD-WAN. So it's a control plane. Even if this control plane goes down, remember all the existing connection between the remote site routers or between managed routers will still keep working.
Okay. Thank you, sir.
Yeah. And that's the beauty of like it's a sales pitch used by Cisco as well sometimes, right? That we have a distributed architecture. Although like Versa has got the same sort of architecture, but not all providers. Okay.
Sir, I have one question here.
Mhm.
So if the V smarts goes down, so you are
Control
saying
plane.
all the control plane information
Mhm.
will be locally installed on these
Mm,
V edges, right?
vSmart. Yeah, vSmart. See, vSmart is responsible to work as a control plane, right? Therefore, it will be
Hmm.
responsible to define a best route,
Hmm.
and then that best route information will be given to the vantage router, right? So vantage routers are going to keep the best route in their routing tables, right? Now, in case if vSmart goes down, right, it does
Hmm.
not mean that branch routers will immediately remove those routes from their routing table. No, they don't, right?
Okay.
There's a timer of 12 hours, right? There is a feature called graceful restart, GR. By default,
Hmm.
GR is enabled between vantage router and the vSmart. So if the OMP peering or the neighborship, the connectivity between branch router and the vSmart goes down due to this GR feature, graceful restart feature, if the vantage router can keep routes in their routing table for next 12 hours. So for next 12 hours, there will not be any problem for entire.
Hmm.
But thereafter, if your vSmarts are not up again in 12 hours, then yes, there is a problem. Then everything will go down. But also you can increase this time. But ideally, you would always have more than two vSmart controllers. So I don't think that both vSmarts will go down at same time, because remember that when you talk about the vSmart, these all are virtual component, right? And you can deploy them in cloud as well as like on-prem, right?
Hmm.
Also in cloud. So if you are
Oh,
deploying your vSmarts on the on-prem servers, then make sure that you do not deploy the vSmarts, all vSmart on a single server, right? So
Hmm.
just in case if one server goes down, gets crashes, right? So again, you would have some other vSmarts up and running. Same goes with cloud. You should deploy vSmarts in different availability zones, right? If you are deploying in AWS, so you can deploy them at different places. So it would rarely happen that all vSmarts, the connectivity to all vSmarts will go down.
So if all the VS Smart go down, or you can say connectivity to the all VS Smarts goes down, so during that 12 hours, will these campus network
The
V edges
IPsec tunnel
will
will
learn
remain up.
will learn the new routes, or
No,
they
no,
will
no, no,
use the
not new, no, nothing. How can it be possible?
okay.
There is no
that's
miracle,
the
right?
same question.
Hmm.
You can't make the changes. The routing table cannot be updated, cannot be modified. Why?
Suppose
Because
suppose one links goes down, then that withdrawn route will be
no, no, no,
propagated
no,
to
no.
the other. Okay.
No, wait. Remember,
Okay. Hmm.
what happens is that let's say there is a branch router, right? And there is a campus router. So all the lane prefix information will get exchanged between them via vSmart. Now, if vSmart connectivity is not up, then how
Hmm.
can they exchange the information?
Okay.
There's no way.
So they won't exchange the control plane information over the IP sector, right?
No, nothing. It's a data plane tunnel.
Okay. Okay.
It's a data plane tunnel.
So in that case, we need a multiple vendors. ISPs.
Obviously, see in SD-WAN, when you talk about the SD-WAN, at least you would have two transports for a customer. You will never depend upon a single transport.
No,
Both
no,
of
that
them
is.
can be internet,
Mhm.
right? Both of them can be internet. Both of them, or maybe one of them is MPLS, the other one is internet. So that's all right.
Okay, so anything's went wrong, so they will do the failover.
Yeah, absolutely. And again, as I said, in Cisco SD-WAN architecture, as per the architecture, even if these all components goes down, it doesn't like there will not be any impact on the existing connectivity. So that's the beauty of this solution.
Sir, V1 timer also is there if in case down. Vsmart is 12 hours. V1, sorry, V manager sir,
Now, I've said all, right?
for 12
If
hours.
all goes down, there will not be any impact on existing connectivity. Although you will not be able to make
Till
any
12 hours.
changes. You will not be able to make any changes into routing table. You will not be able to modify the configuration. You will not be able to do anything. You will not be able to onboard a new branch router. You will not, even if you reboot a branch router, that router will never come back up, will never be able to participate in the fabric again. So, but there will not be an impact on the existing connectivity. Okay.
That's why interested all companies in SD-WAN, sir. Maybe.
You can say that, but for a smaller customer, there is no ROI on it, right? A return on investment, because the customers will always look for the return on investment, right? So if they see that, okay, there is no ROI for them and it's just a capital investment, which they have to make to deploy the SD-WAN, right? Then ideally they don't go for it. Especially the small customers are not migrating their network onto the SD-WAN. Although, like Airtel in India, especially the Airtel, the Tata, right? These two providers are offering the SD-WAN connectivity even for the smaller customer. What they say is that we will give you the shared controller access, and then we will provide you the SD-WAN connectivity between your remote sites, right? So the Tata and Airtel, they are offering for even for the smaller customers, right? Not only for the large enterprise customers. But again, it's a totally call of a customer who need to make this decision whether they wants to migrate their existing infra onto SD-WAN technology or not.
Sir, one more
Okay,
question
sir.
here.
Thank you.
The control plane information between the VSmart and the VH would be exchanged over the IPsec tunnel, or we have
There
anything
is
else for that?
no IPsec tunnel actually. The IPsec tunnel will always be between the WAN edge router, but there is a secure tunnel that we call either TLS or DTLS.
Okay, okay, okay.
So those tunnels will always get formed between the WAN edge router and the control components.
Okay, okay.
That I will discuss later, right? And not only through those tunnels, in fact, there is a overlay protocol that we call as OMP, overlay management protocol, that will always be running between vSmart and the WAN edge router. So OMP neighborship will come up, and then OMP updates will carry your routes information. Okay, that we will discuss later on.
Okay, sir. Thank you.
Now, remember that one more thing here, that even I think I made this statement yesterday. I don't know, but yeah, let me make this statement again. When it comes to the control components in Cisco SD-WAN technology, all these components are virtual components. So if you even ask Cisco that, hey, I need a hardware vManage, so that's not available. If you say hardware vSmart, no, it's not available. So all you can do is that either you can deploy them in a cloud, the public cloud like Azure or AWS, or maybe if you have on-prem virtualization like ESXi, right? Or maybe KVM, right? As an hypervisor. So on top of ESXi or KVM, you can also deploy the vManage, vSmart, right? However, this is not a true statement for the vBond. Why? Because vBond is not a different component. It's a WAN edge router itself. It's a WAN edge router. So whenever you deploy a vBond, you pick a WAN edge router and you make it a vBond, right? So vBond is not a separate component. It's a vEdge itself, WAN edge router itself, right? And only vEdge can be a vBond. Remember, only vEdge, not cEdge, right? So only VIPTEL edge router can act as a vBond. So when you have a VIPTEL edge router, there is a command that we execute on a router to make it a vBond. Now, the vEdge router can be a physical router, like these routers can be physical or virtual both, because if you are deploying them in cloud, then you have got a virtual routers for cloud, and then you have got physical routers for DC campuses and remote branches, or maybe for colos and kind of thing. Therefore, the vBond can be either virtual or physical. But why would you waste your money by keeping a vBond as a physical device? Because at the end of the day, it is just an orchestrator, and it does not participate in data plane. So not much data will go through this vBond. So why would you have it? Why would you have a physical router as a vBond? It's better to have a virtual router as a vBond, right? So again, it is like in most cases, the vBond is also going to be a virtual device. You should have a virtual vManage, virtual vSmart, and virtual vBond. In our lab, right, we have virtual vManage, virtual vSmart, virtual vBond, and even virtual managed routers. We do not have any like kind of physical routers. We only have got virtual routers. Now here you can see that routers can be either physical or virtual. You can deploy your components on-prem or cloud. The SD-WAN is also supporting zero-touch provisioning. So in beginning, like today, I made a statement that all managed routers must have the vBond IP address so that they can talk to vBond. But zero-touch provisioning is also supported. And when I say zero-touch provisioning, which means that you do not touch your router. You do not even define the IP address of the vBond, and still it get to know that what is the IP address of the vBond, and then it will connect to that vBond automatically. And that's called zero-touch provisioning. That you don't even take the console access of the router. You just go and plug the power cable and plug the network cables, and that's it. That's it. So that's zero-touch provisioning. Separation of management control and data plane, obviously that's what you have done, right? Choice of topologies with point and click, like whether you want to have a full mesh connectivity between remote sites. You want to have hub and spoke type of connectivity, because the default behavior of the Cisco SD-WAN is to give you full mesh connectivity. But then you can also implement hub and spoke or partial mesh, right? So you can also have a partial mesh topology. Flexible connectivity with any WAN technology. So as I told you, you can use any WAN technology, whether it is MPLS, 4G LTE, internet, lease line, or broadband type of connectivity. Secure segmentation is supported by Cisco. So like VRF is much in use here. So without VRF, you can't implement Cisco SD-WAN. So Cisco has used VRF a lot here in this solution for the segmentation purposes. Like if you have got different, like within an organization, you have got different departments, and you want them to be in different segments, or you want those different department users not to talk to each other. Like for example, you have got corporate user, but if you are a financial institution, or let's say you are a bank, right? If you are a bank, then you have got one network for your users. The other network is for POS machines, right? For POS machines. And the POS machines have got some compliances, right? And you must follow those compliances. Like the network for the POS machines must be implemented, must be deployed in hub and spoke fashion. Whereas for corporate users, you might want to have kind of full mesh connectivity. So for different networks, you might require a different topology, as well as you don't want them to communicate with each other. So that's where the segmentation or the use of VRF or VPN, because here you also call it VPN or you call it VRF. So that kind of segmentation can be done by the help of APN or VRFs. Single pane of glass, as I told you, the vManage would work as a single pane of glass for you. You would be doing everything on vManage, everything. When I say everything, which means the management, I mean, from design to implementation, I mean, making configurations, and then even to perform troubleshooting, monitoring, everything. Not only that, in fact, if you have a plan to upgrade your devices, even the software upgradation will be done from vManage for all components. Critical traffic redirection with application aware routing. So in SD-WAN, the routers comes with a feature called application aware routing, which means that on a router now you can create a policy that, hey, for YouTube, send the traffic through this circuit or that circuit. For SIP session initiation protocol, with that's what we use in voice over IP, right? So for SIP, use this and this or that circuit. So that's what you can do. So the routers have got that capability as well. On the control plane security, as I told you, so for data plane security, we have got IPsec tunnels, and for control plane security, we have got DTLS or TLS tunnels. Cloud readiness, you can integrate SD-WAN easily with SaaS-based applications, software as service, and also you can integrate it with infrastructure as service, IaaS, right? So it's a cloud-ready technology. Enhanced routing functionalities with overlay routing. So for overlay, they have launched a new protocol, right? Cisco has launched a new protocol called OMP, Overlay Management Protocol. That's a Cisco proprietary protocol, right? You cannot implement OMP on any other vendor specific devices. So for overlay routing, like as I mentioned before, the routing information between managed routers and the vSmart will always get exchanged, right? But that would be done by OMP. So OMP will be running as a protocol between vSmarts and of course between vSmart and the managed routers, so that managed routers can get exchange or can exchange their routing information between each other via vSmart in the form of OMP updates. So OMP is a new protocol that was introduced by Viptela, and it was a Viptela, like obviously this whole Cisco SD-WAN technology is a Viptela SD-WAN technology. So early on, Viptela launched this OMP protocol, but once Viptela was acquired by Cisco, then this OMP also became Cisco proprietary protocol now. So OMP is the new overlay protocol, and it does not support any other protocol in overlay. It is only going to support OMP. So you do not have any much or more choices other than OMP for overlay routing. Obviously, in lane side, you still have to use your traditional routing protocols such as BGP, ICRP, OSP, FISIS, or whatever you want to use for lane side routing. But in overlay, you have got only one option, which is OMP. So that's overlay routing. SD-WAN versus DNA versus SDN, right? So as I already given you this example, right? So,
sir, one question here. Can we cancel the zero touch provisioning and do the manual configuration?
Yes, you can.
Okay.
You can. It's not like you have to cancel the zero touch provisioning. You don't have to cancel that out. For zero touch provisioning, there are some prerequisites. You need to fulfill those prerequisites. If you do not have those prerequisites available or fulfilled, then you cannot achieve the zero touch provisioning. Okay. And in most cases, I have seen that customers are not using zero touch provisioning. They are doing some work at least manually.
Okay.
Yeah.
Because in Arista we have to firstly cancel the zero touch, then only we can configure everything. If you deploy new. Okay.
Here in Cisco, there are some prerequisites before you go for the zero touch provisioning. Do not fulfill them. Simple.
Okay.
Right? Do not purchase any kind of like GTP portal or something like that. Do not purchase those services from Cisco. So you will have to make some configurations manually on your routers then.
Okay.
So guys, I will keep it short again, and we will continue tomorrow. Again, we'll talk about this architecture. In meantime, please revisit what we have covered so far, and tomorrow again in some more details, I'm going to discuss each and every component that are participating in this architecture.
Sure, sir.
Thank you. Thank you, sir.
Thank you, sir.
Yeah,
Thank
see
you.
you
Take care.
tomorrow.
Thank you, sir.
Yeah, bye.